Friends, myself Ghanshyam Dhomse. Today we are going to see the topic hierarchical clustering and agglomerative clustering. Hierarchical clustering is an algorithm that builds the hierarchy of the clusters. This algorithm starts with all data points assigned to the cluster of their own. Then two nearest clusters are merged into the same clusters. In the end, the algorithm terminates when there is only a single cluster left. The result of the hierarchical clusters can be shown using dendrograms. Dendrograms can be represented as, look at the following figures. At the bottom, we can start with the 25 data points, each assigned to the separate clusters. Two closest clusters are then merged. We will have just one cluster at the top. The height in the dendrograms at which two clusters are merged represent the distance between two clusters in the data space. The best choice of the number of clusters is the number of vertical lines in the dendrograms cut by the horizontal lines that can traverse the maximum distance vertically without intersecting the clusters. In the above example, the best choice of number of clusters will be the 4, as the red horizontal line in the dendrograms below covers the maximum distance between A and B, and it is measured by vertical distance. The algorithm has implemented above using the bottom-up approach. The decision of merging the two clusters taken on the basis of closeness of these clusters. There are multiple metrics for deciding the closeness of the two clusters. Here we are using Euclidean distance. Now, what is the difference between k-means and hierarchical clusterings? Hierarchical clusterings can be handled the big data well, but k-mean clusterings can. This is because of time complexity of the k-means is linear while the hierarchical clustering is the quadratic. K-means clustering, since we start with the random choice of clusters, the result is produced by running the algorithm multiple times might differ, while the result of reproducible in the hierarchical clustering. K-means clustering is found to work well when the shape of the cluster is hypersphere, like 2D or 3D. K-means clustering requires the prior knowledge of K, number of clusters you want to divide your data into. But you can stop at whatever the number of clusters you find the appropriate in the hierarchical clustering by interpreting the dendrograms. Now, what are the applications of clusterings? Clustering has the large number of applications spread across the various domains. Some of the most popular applications are recommendation engine, market segmentation, social network analysis, search result grouping, medical imaging, image segmentations, anomaly detection. Hierarchical clustering is based on the general concept of finding the hierarchy of partial clusters, built using either bottom-up or top-down approach. More formally, they are called as agglomerative clustering. Agglomerative clustering, the process starts with the bottom. Each initial cluster is made up of a single element, and the process by merging the two clusters until the stop criteria is reached ensure the nearby points end up with the same clusters. In general, the target has sufficiently small number of clusters at the end. Now, before going to see agglomerative clustering, what do you mean by Euclidean distance? Now, suppose according to Euclidean distance formula, the distance between the 2 points in the plane is coordinated by x and y, and a and b is given by. So, by putting the formula, distance between x and y, a and b is measured by Euclidean distance formula. Now, suppose let's take an example. Euclidean distance between the point 2 and -1. -2 and 2 is founded by using following ways. Now the answer is 5. The horizontal distance between the point is 4, while the vertical distance between the point is 3. 4 is the horizontal distance and 3 is the vertical distance. So in this way we can calculate the distance between the points 2 comma -1 represented as x and y, and -2 comma 2 represented as a comma b. What is the another way to calculate the distance is Pythagoras theorem. By using Pythagoras theorem, we can also calculate the distance. Suppose one edge is 3, second edge is 4, 3 square plus 4 square, that is equal to 25, and the length of that edge is 5. Okay. Agglomerative method. Agglomerative method or bottom of clustering method, each clusters can contain one data point. Okay, then compute the similarity between each clusters and join the two most similar clusters. Finally repeat the steps 2 and 3 until there is only a single cluster left. The related algorithm is shown below. Now in this algorithm what happens, starting with the number of objects, here a set of x object is there, x1 x2 up to the xn. Now here we are using to measure the distance between two clusters, we are using a distance function. Distance function is denoted by dist in bracket c1 comma c2. Here c1 and c2 is represented two different clusters. Now start with the collection of C with n number of singleton clusters. So C of I is equal to x of I. It means a number of clusters are there is represented by x of I. Then repeat the process until one cluster is left. Now find the pair of clusters that is closest is measured by the distance between two clusters. Now if you see the diagram, if you see the algorithm here, the distance between the cluster I and cluster J is measured by minimum space distance function C of I, C of J for all C of I and C of J. One thing is remember that C of I, J is the two different clusters and their distance is measured by using minimum distance function. Now merge the clusters C of I and C of J into new clusters C of I plus J. Then remove C of ij from collection C. Finally we can add C of I plus J into the C. Now in this way we create dendrograms, that is nothing but tree of hierarchical clusters by using this agglomerative clustering algorithm. Now before any clustering is performed, it is required to determine the proximity of matrix containing the distance between each point using distance function. So what is the important point here? Need to define the distance matrix over the cluster is important part. Now the matrix is updated to display the distance between each clusters. Now what is the advantages of agglomerative clustering? It can be produce an ordering of the object which may be informative for the data display. Smaller clusters are generated which may be useful or helpfully for discovery purpose. Now look at the following example of agglomerative clustering. Here there are the different ABCD, these are the different data points are there. Here if you observe two different arrow, left side distance threshold, when our dendrograms is created, that is nothing but the tree of hierarchical clusters are created, and when we cut that tree of hierarchical clusters we will get the number of clusters similarly to the k-means clustering algorithm. Now in the right side of the diagram, if you observe the number of clusters, so we want to see the relationship between distance threshold and number of clusters. Whatever the distance we are set, we will get the number of clusters, and finally we will got the diagram like dendrograms. Now let us start with the example. Now in this example, if you observe A and B, these are the two different clusters pair. Now to measure the distance between A and B, which is very close to each other, the diagram shows the distance between A and B and it form one single clusters A and B. Look at the another. To measure the distance between J and K, we form the another clusters and the distance is cluster is represented by J and K. Look at the another distance between C and D. We represented another clusters C and D. Look at the another clusters. Now the clusters A and B and C and D is form a new clusters. Look at the figure at the leftmost part. Now another cluster is may join with this previous cluster, that is Z. In this way the diagram is joined cluster by clusters. Now all these clusters are merging to each other. Finally we will get the final diagrams of dendrograms. So agglomerative clustering, if you want to see how many number of clusters you want, you simply cut that diagram in the horizontal way. Now look at the following diagram. Suppose you cut that diagram at a particular distance, you will get the number of clusters. Now look at this right side. If you set the threshold distance for 40, you will get the number of clusters like this. If you set the distance threshold for 100, you will get the number of clusters like this. So in this way agglomerative clustering is happen. Now there is another types of clustering, agglomerative versus divisible. Divisive clustering, in this case, initial stage of single cluster with all samples, and the process is proceeded by splitting the intermediate clusters until all the elements are separated. At this point, the process is continuous with the aggregation creation based on the dissimilarity between the elements. Now, the major difference between agglomerative and divisive is agglomerative clustering is based on the distance between the two different clusters, and the divisive clustering type of approach is based on the dissimilarity between the two elements. Now divisive method is the top down clustering approach, while the agglomerative clustering is the bottom up approach. We assign all the observations into single clusters, then partitions the clusters to the two least similar clusters. Finally we proceed the recursively on each clusters until there is one clusters for each observation. There is an evidence that divisible algorithm produces more accurate hierarchies than agglomerative algorithms in some circumstances, but conceptually more complex. References, whatever the images I put here taken from these references. Thank you.